Hello.
There we go.
Good morning. I'm Nicole Kawanko, computer science teacher to this great group of students, and today very dapper looking group of students from the Urban Assembly Maker Academy. We would like to thank two very special guests for coming, from the New York State Board of Regents, Regent Mead and Regent Reyes. Also, we'd like to welcome from the New York State Energy Research and Development Authority, Emily Dean, Director of Market Development. And thank you to everyone today just present here coming to support our kids. Our students created a proposal to replace a very outdated lighting system at our school. They will outline how they acquired the skills and knowledge to accomplish this task, why they undertook the challenge in the first place, and how they applied these skills to create the program. I am very, very proud of the work that they put in with John, Tom, and Mike, and I'm really excited for you guys to get a glimpse of their progress. Here are our first presenters.
Thank you, Nicole. Hi, my name's Alim. I'm part of the Stacks+Joules program. We are juniors and seniors at UA Maker Academy. We are committed to the Stacks+Joules program for entry to BAS industry.
Hi everyone, I'm Thomas Robb, and I'm here guys to talk to you guys about BAS. Now I bet you know what that stands for. It stands for Building Automation Systems. Now BAS will save us approximately 29% in energy consumption, and in the case of schools, 49%, saving us the big bucks.
Hello, my name is John. Here at Stacks+Joules, we are learning and programming using Python so that we can understand and interact with the control system that runs the vital services in large buildings in New York City.
These are our partners. They are leaders in their field and in our industry.
The goal of the Stacks+Joules program is to obtain entry-level jobs, paid internships, and advanced educational opportunities for students in the industry.
In the building automations industry, there's a serious workforce shortage. There are thousands of well-paying jobs open in New York. According to the graph, the entry level earns $35,000 a year, and as they progress, gain experience, they can earn up to $74,000 a year.
In Stacks+Joules, the hands-on training prepares us for a certificate in lighting control and a certificate in the Niagara 4 system, one of the dominant controls in BAS in New York City.
When you go for an interview or a job, they tend to look for certain characteristics such as teamwork, communication, and responsibility, which are taught to us at the Stacks+Joules program. These traits are essential and valued to superiors, employers, and fellow employees. They are necessary to be more organized and more productive in our everyday workspace.
Hi, my name is Brian. We would like to tell you how we have been preparing to build our tech skills. So, we have visited our partner RAB, and two of RAB's employees, Davis and Ravi, have come to visit our class and trained us their lighting control systems, their light cloud systems, and their Wi-Fi control systems. Thank you.
Hello, my name is Sumaya.
Hi, I'm Fiola. Okay, so we basically did a lighting lab in which we tested multiple lights to find out their temperature, foot candle, and wattage to figure out which light bulb would be the most efficient. We also conducted an audit of the school where we took inventory of all the lights, and this was transferred to a spreadsheet that was sent over to RAB, and they created this plan.
So my name's Yinsen, and that's probably hard to say, but our main call to action was the Climate Leadership and Community Protection Act, which demands that New York State must reach carbon-free electricity by 2040.
most of our electricity is produced by natural gas, 42%. Wind power and solar are less than 6%. We need to reduce the energy use to meet our goals.
Oh, you don't have the balloon? Technical problem.
Well, while we wait for Tom, let me just introduce myself. I'm Nicholas, and as you probably guessed, I'm part of the Stacks+Joules program. Alright, so imagine this balloon represents the New York State's energy demand, right? And as the energy demand gets larger, so does the amount of natural gases we use. Alright, so as you can see think about my fingers as our wind and solar power energy, right? So wind and solar only stop this balloon from getting any larger, right? But by doing minor modifications to older buildings like our school, we can slowly release more and more gas until we eventually reach our goal of 0% carbon emission.
Hello, my name is Christopher, and we are the future of New York City. We want to take responsibility to secure the future, not only for ourselves, but for the community and future generations.
So our proposal consists of 3 things. Basically, improving the light system at our school to give us a brighter education space, reducing the amount of electricity we use, and reducing the amount of carbon emissions we use. Doing all that will save you guys a whole bunch of money.
The first step is to replace our outdated light fixtures with LED light fixtures, which is equipped with a controller, allowing it to communicate with our new light cloud system.
The light cloud system has lighting control strategies, which consist of task tuning, which allows us to set a light output at any level that is needed than its true capability for certain situations. Scheduling, which can turn on, off, or dim lights and activate scenes easily, which can be repeated daily, weekly, monthly, yearly, and on specific dates. Daylight harvesting, which calculates lights that the natural light is coming in and will dim the light according to the natural light. Occupancy and vacancy, which will turn on, off, dim lights, or activate scenes easily based on motion and sound in space. Personal control, the ability for an individual to adjust the light level to their personal preference within the space or a zone.
Let's do some math. So our current school system uses around 900,000 kilowatt hours per year, and just by installing the LED lights, we'll be saving about 45% of that. And then with the included light cloud system, that'll increase to 70%, which is a total savings of 650,000 kilowatt hours per year. Now, what does that mean in carbon emissions? Well, for reference, 1 ton of carbon is equal to 550 cubic miles of CO2. That's a cube the size of Washington, D.C. Our current system emits about 659 tons of carbon every year, and with 70% savings, that reduces that to only 195 tons of carbon every year. But what does that mean in savings? So we currently spend around $200,000 every year, and saving 70% of that is $150,000 every year, and that's what I call a return investment.
So, $44,000 covers the cost of the lamps that have failed or broken and the cost of maintenance and labor in order to replace these broken lamps. However, because we negotiated a 10-year warranty that covers the cost of the lamps and the cost of the maintenance and labor needed to repair them, the amount you would spend is equal to 0.
Alright, so I'm back again. So this time I'm here to discuss the entire cost for this project, right? So overall, this project cost about $1.1 million, right? So let's break this down. We have about $920,000 of that going to the lights with the light cloud system, which, as you heard from River, would increase our efficiency by 7%. Then we go to our anticipated Con Ed rebate, which would reduce that by about $240,000. And we go to our equipment subtotal, which is about $690,000, and then estimated labor cost about $480,000.
Hi, my name is Marlon, and our current existing system has a maintenance cost of around $400,000, while the electricity bill itself would cost around $2.1 million, which costs us a lot of money, as you can see. But with our new project, the project cost itself is $1.1 million, while the electricity cost is around $600,000, which saves us a lot of money. And our 10-year savings is due to the fact that we have maintenance warranty, so we get maintenance for free for 10 years, and we don't spend anything on the maintenance itself, on changing anything. So we save around around $800,000.
In essence, when this plan is enforced, we will succeed in meeting every single one of our goals. We must replace the old lighting that's often seen in a majority of New York City public schools with our new state-of-the-art system. This will improve the quality of our learning environment and better our education.
One of our biggest goals is to reach 100% energy efficiency by 2040 while being considerate of our environment and state. We will do this by reducing electricity usage, not by 50, not by 60, but by 70%. This means that we will also reduce carbon emissions by 4,640 metric tons.
Hello, my name is Shirley. Adding on to what Samaya just said, we will not only be reducing carbon emission, but we will also be reducing our school yearly budget by saving up to over $800,000 for over 10 years.
You have the power to improve our learning environment. These energy-efficient lights will better our education by giving us a brighter space to engage on our work. We will be taking action towards attaining carbon-free electricity by 2040 in New York City. The carbon footprint of our school building will greatly drop. Furthermore, the drastic amount of funds we'll be saving will benefit the state year by year. We ask that these saved funds goes towards programs like Stacks+Joules all around the city. Every journey begins with the first step. Let's take ours together. Thank you.
We'd like to give a very, very special thank you to the team at Rab Lighting. Without the help of Ravi and Davis, none of this would have been possible. As you can see, we have tables in the back with displays and demonstrations. We encourage you to engage the students and ask any questions that you may have about the program and our proposal. Thank you so much.